All right, all right, all right. It is time for some rational functions review. And this is going to be exciting. You know how I know this is going to be exciting? That little guy right there is telling me that this is going to be exciting. And Rivdar Jenny here is along for the ride, right, Jenny? She's already fallen asleep in class, as usual. But that's not what you guys are going to be doing here because, again, exciting lesson. All right, let's hop to it. Much of this will be review. I am going to pepper in some newer stuff for you, but let's hop to it. And you know when that new stuff comes in, you're gonna be ready. All right. So first thing we always do with these rational functions, I like to not just I like to, everybody likes to factor. It's my favorite thing to do. I love factoring. Jenny, you perk up? You heard factoring? You're like, heck yeah, brother. Let's do some factoring. I think so. Okay, let's do it then. So what multiplies to 12 and adds to 8? That's going to be x plus 6 and x plus 2. If you cannot factor, you're in big trouble, okay? We have to be able to factor. Got to be able to. All right. So let's see here. We've got a little checklist going on here. So what's our domain? Let's address the domain first. Well, the domain is anything that I have to exclude when it comes to rational functions. What can I not divide by? Because this is a fraction. We have a polynomial over a polynomial, right? That's what we have here. This is a polynomial divided by a polynomial. What can I not divide by? I can't divide by 0. Well, what's going to make my denominator 0? That would be -6 and -2. So I need to write my domain as something like this. X such that x cannot equal -6 or -2. And depending on how we're inputting these things in, some might ask for interval notation. This is set builder notation. But if it doesn't specify, it's up to you, I guess. All right. We're going to skip over range for now. I think that's a little bit easier to address when we see the graph. All right. Next thing I actually do want to address here, I'm going to skip all the way down to F here. Vertical asymptotes and holes. So how do we address those? Well, if something cancels like that, that is going to be a hole in the graph. And what's my x value right there? That's going to be -6. And we are going to find the other part of that ordered pair here in just a moment. We could say there's a hole at x equals -6, but I'm going to go through how to actually find the other coordinate. So my simplified form now is 1 over x plus 2. So what's left in the denominator there? Well, that's going to be how we're going to find our vertical asymptote. So what is x going to equal there? That's going to be x equals -2. And you have to write that as x equals -2 because it's not just some number -2. It's an equation of a vertical line. And we are going to draw that in there with a dashed line for our asymptote. All right. Awesome. Let's see what else we got here. How about our horizontal or oblique? This is something we're going to bring in this year. Okay. You've seen horizontal, but you haven't seen oblique yet, at least not to my knowledge. Let's talk about our horizontal asymptote rules. If we have a small exponent or degree, rather, a small degree over a large degree, it's going to be y equals 0. If we have...
Okay, I found this on the web for y equals 0. Check it out.
Thank you, Siri. All right. If I have same over same, Siri is always listening, just like you guys should be listening right now. We're going to have y equals our lead coefficient over our coefficient. And if it's large over small, there's no horizontal asymptote, but this is where we're going to get into the oblique or slant asymptotes. So this is where we're going to get a little more information here in the coming days, all right? So for this particular one, you may want to jot that down, by the way. Pause it and jot it down if you need to, if you don't remember those. For this particular one here, it's small degree, a degree of 1 over 2, so small over large. That's going to be y equals 0. Wonderful. All right, so I'm going to start graphing. Actually, you know what? Let's talk about x and y intercepts, shall we? That's another thing that's going to be useful for graphing this. So how do I find x and y intercepts? Well, let's think here. When I am crossing my x-axis, what's my y value going to be? My y value is going to be 0, right? When I'm crossing my x or my y-axis, what's my x value going to be? Well, my x value is going to be 0. Anywhere along here, any point along here where it's here or here or here, all those, it's going to be 0 comma something, 0 comma -5, 0 comma 1, 0 comma 7. All those are going to be 0 for my x value. So to find my y-intercept, I'm going to plug in 0 for x. And we can look at our original equation usually pretty easily. If I take a look, I'm going to use a different color here to highlight it. If I plug in 0 for x, I'm just left with these two, which is 6 over 12. So my y-intercept is going to be 0 comma 1/2. I like it. Now my x-intercept, if I set this equation equal to 0, I'd only want to have my numerator as 0 because we know we can't divide by 0. We don't want to have, 0 divided by 0. That's the indeterminate. That doesn't work. So I want my numerator to be 0. How is my numerator going to be 0 if there's not even an x up there? Okay? And in the original, you might be like, well, what if I plugged in -6? But we already know that's restricted from the domain, so we can't do that. All right, so in this case, there's not going to be an x-intercept. And you'll actually see we have a horizontal asymptote there. It's generally avoiding those. It can cross, generally avoiding. All right, so we don't have any x-intercepts in this one. None. And then my y-intercept, I don't know why I wrote it down there the first time. There was a spot for it. My apologies. All right, 0, 1/2. Maybe I'll pop back to the blue marker. All righty. So I have enough to really graph this thing pretty accurately now. So I'm going to throw in my asymptotes. I'll actually use a different color for the asymptotes. I'm going to go with, let's go with the pink again, actually. So we'll go with our y equals 0. Horizontal line. And my vertical asymptote was x equals -2. This will show up a little better than the blue since we're overlapping. And then for my graph, let's see here. I said my y-intercept is 0, 1/2, which is right here. So that tells me then my graph, wow, that was, I'm going to try that again. That was just, it's a little tough to write on this thing. Let's see if coming from this direction helps. There we go. That's a little better. So I know that graph is going to end up over there because of my y-intercept. And because I don't have a squared binomial determining my asymptote right there, like if it's not x plus 2 squared, I know the other one's going to actually be right over here. And we're going to do a little more exploring with numbers to really show how we actually also, another way of showing that what's going on at those asymptotes, okay? So let's see here. Let's find our range now, right? We avoided that one earlier. What's our range? Well, I go from -infinity all the way up. What am I avoiding here? Up here at y equals 0, there's no values there for my function, so I'm skipping over that and then continuing on. So we could even say in the same form, y such that y cannot equal 0. Or if we did interval notation, from -infinity to 0, union 0 to infinity, all parentheses all the way there because we're not including the 0. All right. I'm pretty good with this so far. So really up to this point, guys, this is all pretty much review here, right? This is a very complicated chat. There's so many steps, so much going on, but this is all pretty much review. Let's talk about the end behaviors. I mean, what's going on over at the ends here? What happens as it gets, as we go closer and closer, as we go larger, as x approaches infinity? So I'm actually going to rewrite this. We'll say as x approaches positive infinity, what's happening to the graph? Well, our y or our x or f of x, what's that approaching? Well, it keeps getting closer to this asymptote. It keeps getting closer to a value of 0. And as x approaches -infinity, we're over on this side right over here, right? We're, again, getting closer and closer to 0. So f of x approaches 0 once again. Now, I wonder if we could perhaps use our graphing calculator to showcase this. So I have the equation already plugged into my calculator here. And what I'm going to do is I'm going to hit second table set, and I already have it. Okay, so see how I have here, independent variable, ask. I'm going to just type in numbers larger and larger in the positive direction and in the negative direction, and we're going to see what happens, okay? So if I go to second table now, I can type whatever I want, and the calculator will do the math for me, right? So if I were to type in, say, 3, okay, I get 0.2. If I were to go bigger, let's say 9, okay, it's getting smaller there. Let's say I go with 16. I'm just picking random numbers here. Smaller yet. How about 100? All right, even smaller, 0.0098. What about 1,000? Okay, what's that mean? E negative 3. Well, if I hover over this value, it should pop up, or not, I'll show it something totally different. But the E negative 3 is saying you're moving your decimal place 3 to the left, right? The scientific notation is basically what your calculator is telling you there. So it's even smaller yet. They're not even typing it in anymore because it's like 0.000. Again, they're gonna keep on giving you these E ones, just showing that it's getting smaller and smaller and smaller. And the same goes in that negative direction. If I typed in negative, I'm going to start with 16. I'm going to get a small value, right? And then if I go to negative 100, they're a little different because this is shifted a bit. But we can already see that it's getting smaller. Negative 1,000. Negative 0.001, and if I go bigger than that, it's going to start getting into those ones with like the E negative 3, E negative 4, so on and so forth, all right? But we can see that it's getting closer and closer and closer to 0, but it's never actually getting there. All right, now what about this whole? We never went back and figured out that Y value. Maybe we could use this table to figure that out, okay? So I'm gonna I guess I don't have to delete these. We're just going to keep moving. If I plug in negative 6 to this, I get an error message, which is unfortunate, right? It doesn't just tell me what it is. What if I were to go with, what if I were to plug in numbers that were around it, okay? And maybe I do need to delete this and give us some more space. So what if I were to plug in some numbers around negative 6 and that are really close to it, and see what happens as I get closer and closer. So how about this? I'm going to go with negative 5.9. Okay. So right now I'm at, and I forgot to actually notate my hole in the graph in the first place. There should be a hole right there. So I'm on this side right here, right? I'm on the right hand side. So as I approach from the right hand side, what's happening? Well, okay, I get that number. And then what about, let's go with negative 5.99. All right. And how about negative 5.999? What number do I appear to be approaching here? It says that. Right? It says that I'm plugging in negative 6, but I'm not. I'm plugging in negative 5.9999, and it's giving me negative 0.25, and it's going to have some 001 going on afterwards, but they're cutting it off. Okay, so it looks like I'm approaching negative 0.25. Well, what about from the other side? What if I did negative 6.1? Okay. And then what about negative 6.01? Getting closer. Negative 6 point. And I'm going to just jump ahead here. I'm going to go with, whoa, I didn't get a decimal place in there. No. I don't know why it's not letting me. There we go. Ooh, that was a voice crack. I'm leaving the voice crack. I'm okay. All right, so we get, so it says -6, but really what's going on there is -6.0001. And we can see, once again, we're approaching that same value. So what we have here is -1/4. And there is another way of going about that. Well, we have this simplified form here, right? Because we canceled out the x plus 6. And I end up with, if I plugged in -6 to the simplified form, right, where I made those cancellations, -6 plus 2, this is 1 over -4, -1/4. And there we go. There's my y coordinate. So although, yeah, you've probably seen that where you plug back in to get the y value, that's not really there, right? That's what it's approaching from both the left and from the right, and it's getting really closer, but it never actually gets to that value, right? But the graph is getting there, okay? It's getting there, and that's what would be there if it was there, but it's a hole. It's not part of that, right? But we can use numbers really, really close, infinitely closer and closer from each side to get a really good estimate and what it would be, right? But you can't actually plug into the original equation. So we're going to work a little more with these tables. We'll present you with some questions as to like, hey, what's going on here based on this table of values? What could you tell me? Is this a hole? Is this an asymptote? You can see as they approach 0, maybe it's a horizontal asymptote, right? A value of 0. If we're getting really close to a common number from both the left and the right, oh, that looks like there's a hole there, right? So there's some different things that we're going to look at here that are a little more advanced concepts than what you've seen before. All right? Beautiful. Wonderful. Fantastic. We got one last part here. Graphs behavior approaching the vertical asymptotes. Well, maybe we can use our calculator to do the same thing. And I'm going to plug in some numbers here to save a little time. All right, so if I'm coming from the right-hand side over here on the graph, I'm approaching it from the right here, and my numbers, if I'm going to plug in some numbers that are really close to -2, I could use some values like, let's see here, what's right next to it there? How about, I'll go with this color here. We'll say that really close on this side would be, how about -1.9? And really close on this side would be something like -2.1, right? And then we can get closer and closer and closer. So what I've done here with my calculator, my table of values, I did -1.9, then 0.99, then 0.999, and then this one actually up here is and we got 4 nines there. But as you can see, the number keeps going up, 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 up. And if we keep going closer and closer and closer, it's just going to keep soaring. It's going to get huge, right? It's approaching positive infinity. And then over here, as I get closer from the left-hand side, as I approach from the left, those numbers are getting really, really negative, right? Large negative numbers. And I'm approaching negative infinity. Okay, so that table of values can show us that, and we can keep on plugging in there, and you'll keep seeing the numbers get larger and larger and larger for our output values. So the way we would write that is, as we approach, as x approaches -2, and if we want to say from the left, we use a little superscript negative up top there, then f of x approaches, and we said from the left-hand side, that's this portion of the graph, right, that it approaches negative infinity. And that can actually help us graph these when we got a bit more going on and we don't have that necessarily that y-intercept, or we're not sure if it's coming up over here. We can use these numbers close to the asymptotes to help us shape the graph. And then as x approaches -2 from the right-hand side, f of x is going to approach positive infinity. And there we go. There's our graphs as they approach the vertical asymptote. Woo! That's fantastic stuff right there. I like it. I love it. Wonderful. I think I'm going to cut this video off here and make a second one with a second problem. So for now, we're going to sign off. All right. America Freedom, rock and roll, and River Dog Jenny just chilling there, falling asleep as usual. Thank you guys for hanging in there. I know it was a lot. Rational functions are a lot, but you can handle it. All right. Peace.